Hello guys, welcome to Ramta Solutions. Welcome to your lesson on grade 11 reduction formulae. We are going to have an introduction of what this reduction formulae is about, and then look at this reduction formula in details. Of course, we're going to relate it with the cast diagram as well. And in addition, we'll also be looking at the reduction formula and the negative angles. And if there's time, we might as well look at co-functions. Okay, so by the end of this video, you will be able to use this diagram that you're seeing in this page. You will also be able to relate these 90 plus, 90 minus, 180 minus, and of course, because you're now in grade 11, you know this cast and what it represents or what it means. So, without any waste of time, let's look at it. As introduction, let me do this. As introduction, I want to say to you, any angle written in the form, let me say written in the form, I will say in a form that is greater, let me say theta greater than 90 degrees, can be written as an acute angle. Okay, it can be written as an acute angle. Okay, so if you have any angle that is greater than 90 degrees, you can represent it as an acute angle. And remember, we are basically referring to your sine, cosine, and tangent. Okay, so you are going to see this shortly. Okay, you are going to see this shortly. Now, let me remind you as well what you used to do in grade 10. In grade 10, you used to plot these functions. Let me say 90 degrees, 180 degrees, 270 degrees, and then 360 degrees. All right. And you, for sine, you had, let me say this is 1, this is minus 1. For sine, you had something like this. All right. This was for sine graph. All right. Let me see. This is for sine graph. And then for cosine, you had something like this. Okay. For cosine graph, you had something like this. This thing is not drawn to scale, but I hope you have an idea of what I'm talking about. And then you also had this function here, which we used to which we call tangent. Okay, which we call tangent. Okay, which we call tangent. Okay, which we call tangent. So this one here is called tan x, and the red one was cos x. All right, the red one was cos x. So in grade 10, we showed you the cast diagram. All right, in grade 10, we showed you the cast diagram. All right, in grade 10, we showed you the cast diagram. And we had said all students take coffee. All right, we said all students take coffee. So this was your cast diagram. All right, this was your cast diagram. So with the reduction formula, what you are seeing that in the first quadrant, if you have whatever angle you can think of, let's call it theta, we can say theta, wherever theta can be. Let's say angle theta is here. Change the color. Let's say angle theta is here. You can see it's 90 degrees minus theta. So this is the first quadrant. So the first quadrant is 90 degrees minus theta. Let's go to the second quadrant. The second quadrant, let me also draw this line here. Let me draw this line here. The second quadrant, as you can see, I want the blue line. Okay, the second quadrant, I want you now to look at the next angle. It is 180 degrees. So we can say the second quadrant is 180 minus this angle theta. All right, we can say it's 180 degrees minus angle theta. All right, 180 degrees minus angle theta. Similarly, we can say it is 90 degrees plus theta. It's okay. 90 degrees plus theta. It's okay. 90 degrees plus theta. It's okay. Okay. Now going to 180 plus. 180 plus. Remember, 0 to 90 is the first quadrant. Let me show you. This is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. And this is 360 degrees. Now, as you can see, third quadrant is between 180 degrees and 270. Let's go. 180 degrees and 270. We can say it's 180 degrees plus or 270 degrees minus. So because we are used to 180 degrees plus, let's just take 180 degrees plus theta. Okay? We will use 180 degrees plus theta. Can you see that? From here, to get this angle, you will say it's 180 plus that acute angle that you got there. It will give you this angle here. Okay, you can also say 270 degrees minus theta, but because we don't work with 270 degrees minus, we'll just take 180 plus, which is okay. All right, we'll take 180 plus. Proceeding, we are then going to the greater than 270 but less than 360. This is the fourth quadrant. We get it? Greater than 270 but less than 360. That's the fourth quadrant. So here we can say it's 270 plus, but we are more used to it being 360 minus. So we'll take it to be 360 degrees minus theta. So all these things that I just mentioned, we refer to them as the reduction formulae. Okay? We refer to them as the reduction formulae. So if your angle is given in these forms, you can write them simply as theta. Theta, which is an acute angle. You're going to have an example where you can see them. Okay? You're going to have an example where you can see how to use these guys. Okay? All right, so let's help you now cast diagram and these guys individually. I'm going to take the 180 degrees minus and the 180 degrees plus. Remember, this is the second quadrant, right? This is the second quadrant, while this is the third quadrant. Right, this is the third quadrant. So let's draw our Cartesian plane. I'm going to do this. I'm going to just take an arrow here, and then I'm going to take another one. Okay, and then Okay. Oh yeah. Now, okay. So I think this one is too big. It's too, fine. Okay, let me do this. Okay, looks almost perfect. Okay, so now what we are now going to be looking at is this. I want you now to remember we said we have 180 minus theta. Your angle here is theta. Let me show it to you. Your angle here is theta. This is your angle here. It's theta. So because I said you can also represent it here. Imagine this is 0, this is 90, this is 180 degrees, this is 270 degrees, and 360 degrees. We are looking, if I were to move from here to here, it'll be 180 degrees, right? But I'm not moving from here to here. I'm moving from here to here. What is this? If I move from here to here, okay, that's okay. And then I also consider this guy here, who moves from here to here. I call him theta. Now, what is this part here? This part here, it is my 180 degrees minus theta. Can you guys see that? This is the 180 degrees minus theta. Can you see that? So, what this means is that this angle in the first quadrant, if you had, for example, x and y, here you will be having negative x and y. Can you see that? You will be having negative x and y. So you will be able to use your SOHCAHTOA over here, okay? You will be able to use your SOHCAHTOA over here. So this angle is 180 minus theta. You can represent it as this acute angle here. Okay, we're going to have more of it later. I think I should change colors. Now, again, we have smaller nyana angle theta. We know if this is 90 degrees, 0 degrees, what is this now? 180 degrees, this is 270 degrees, and of course, revolution 360. We know from here to here is 180. From here to here is 270, right? But what we are looking at is the fact that we don't want to be, as you can see, we have moved beyond 180, right? We have moved beyond 180, and agree with me as well that these two angles, right? Agree with me as well that these two angles, as you can see, are vertically opposite. Can you guys see that? They are vertically opposite. So if this is theta, this will also be theta. All right? This will also be theta. So if this is x, this is y. So this looks like it's a rotation at 180 degrees. So this will be negative x and negative y. Right? It will be rotation about 180 degrees. So then, if you are given an angle that is greater than 180 but less than 270, you can represent it as an acute angle, this angle here. Can you see that? You can represent it as this angle here. Okay, so this is what we mean by reduction formula. This is what it does. Okay, perfect. Now, let us then head to, we should now head to, let me see, we should now head to 360 degrees minus. Okay, we should now head to 360 degrees minus. Now, when we look at 360 degrees minus theta, this is in the fourth quadrant. Okay, this is in the fourth quadrant. Okay, this is in the fourth quadrant. Let me draw it. again. Is it? Then you have it here, and fourth quadrant, you have it here. So let's call, oh boy, we call this one here angle theta. As you can see, this one here could be again angle theta, right? Now, if we're looking at 360 minus theta, moving from here to here, this is our 360 degrees minus theta. Can you guys see that? This is our 360 degrees minus theta, right? This is our 360 degrees minus theta. Hence, it'll now be easier to get this acute angle when you're given an angle that is greater than 180 degrees, but rather 270 degrees, but less than 360 degrees, right? So this is what you can do. So now, not only that, I would also like to look at your negative angle. I would also like to look at your negative angle. So when you look at your negative angle, here, we're looking at clockwise measuring. So we're measuring things clockwise. Okay? We're measuring things clockwise. Okay? So positive angles, as you know, they like this. So with this one, we mean they like this. With this one, we mean they are like this. Okay? So now what we are going to do now is simply, let's look at it from our Cartesian plane. Okay? From our Cartesian plane, I need to reduce it. Okay, maybe let me shift it a bit. Okay, it's fine. So it will be negative angle, considering it's an acute angle, okay, considering it's an acute angle, measured clockwise, it will be like this. Okay, let me return that stroke, and yeah, return the stroke, the line, here is it. Okay. Okay, so when it's a negative angle, we measure it anti-clockwise. So here is your negative angle. Now note, I want you to note some few things. 180 degrees, 270 degrees, and of course 360 degrees. Now, as you can see, with our negative angle, it is in the fourth quadrant. All right, it lies in the fourth quadrant. It lies in the fourth quad. In the fourth quadrant, cos theta will be positive, and then sine theta is negative, and tan theta is also negative. So what we mean, whenever you see a negative angle, always write it as a positive if it's cosine. Meaning if you have negative cos negative 30, you must write it as positive cos 30. If you see sine negative 30, you must write it as negative sine 30. Okay, let me expand on this. Example, cos negative 30, check your calculator, will be equal to cos 30, which I think is root 3 over 2, right? Sine negative 30 you must say it is negative sine 30. Your calculator will return negative half. Okay? Your calculator will return negative half. And then tan, let's look at it. Tan negative 30 must be written as negative tan 30 because it's in the fourth quadrant. Now, I believe tan is root, what is this? Negative 1 over root 3. I think your calculator returns negative root 3 over 3. Please confirm these values on your calculator. Please confirm them. Your calculator must be returning these. All right? Your calculator must be returning these. Okay. So recall, whenever you see negative angle, cosine will always be positive. Sine and tangent will be negative when you see negative angles only. Okay? When you see negative angles only. Okay. Perfect. Now, let's now consider cofunctions. Let's consider cofunctions. Let's now consider cofunctions. So with cofunctions, you have, for example, you should know, let's try plotting these functions here. Okay. I want to try 90 degrees, 180 degrees, 270 degrees, 360 degrees. Let me extend it. Okay. So we have this, looking at sine. Okay, this is 1, this is -1, you are 0. So this is your sine graph. And then your cosine, it'll be like this. Let me change the color. So cosine will be like this. All right, cosine will be like this. I think the arm is too long there. Yeah, it's better here. Okay. So now the blue one is cosine. The blue one is cosine. The white one is sine x. Right? So I want you guys to notice something. I want you to try this on your calculator. Please try sine. I'm going to say sine 30 degrees. Then I also want you to try cos 60 degrees. Tell me that sine 30 degrees is half. Again, also tell me that cos 30 degrees is also half. Right? Okay. All right. So as you can see, for cofunctions, the angles must be supplementary. Okay? The angles must be supplementary. Okay? The angles must be supplementary. So in other words, let's say one is angle A. Let's say one is angle A. The other is angle B. Together they must be 90 degrees. So they must be complementary. As you can see, 30 degrees and 60 degrees. Together they equal 90 degrees, isn't it? So I'm going to continue with this. I'm going to continue with this and say, all right, if that's the case, how about I say, I said A plus B equals 90, and we said A is equal to 30 degrees, and then B is equal to 60 degrees, right? This is interesting. Now, I remind you, sine 30 degrees is basically equal to, let me take this one here let me take this one here as a reminder. 30 degrees plus 60 degrees must be equal to 90. You will then agree with me that 30 degrees is equal to 90 degrees minus 60 degrees. In the same way, 60 degrees is equal to 90 degrees minus 30, right? Please hold. So we can say sine, what is this? Is 90 degrees minus 60, isn't it? I want you to hold it for now. It's 90 degrees minus 60. Leave a space a bit, or 2 lines, cos 60 degrees is equal to cos, what is 60? 60 is 90 degrees minus 30 degrees. Now, what we do normally, we can say this. We can say, okay, when I see 90 degrees, the sign will change to cosine. So this will be cos 60 degrees. When I see 90 degrees, cosine will change to sine. This will be sine 30 degrees. So this is the reduction formula. Okay? This is the reduction formula. Okay? This is the reduction formula. Therefore, we say sine and cosine are cofunctions. Right? They are cofunctions. Okay? They are cofunctions. So, remember, you have proved that cos 60 was equal to half. You were also able to show that sine 30, you didn't prove, you found cos 60 was equal to half, sine 30 was equal to half. Can we not therefore say cos 60 degrees equals sine 30? Yes, this is what we are saying. Sine 30 is equal to cos 60. That's what we are saying. So this is how you're going to deal with cofunctions. Okay. All right. Now, let's get to examples so we can get to see all these things in action. Example 1 will say if t equals sine 43 degrees, express the following in terms of t. Express the following in terms of t. Number 1, sine 317 degrees. Number 2, cos square 403 degrees. Number 3, tan negative 43 degrees. Okay. And I think before we proceed, if you have, but it's okay, we can proceed. If you have angles greater than 360, please try to minus multiples of 360 from whatever angle that you're looking at. Okay? If k is greater than 360, or not k rather, if your angle is greater than 360 degrees, minus multiples of minus that number with multiples of 360. You will get to see that shortly. Okay? All right. So now let's get to our solutions of these. Something that I want you to see in our solution, something that I want you to see is this. We said we are looking at, let me do this. I'm just going to do it like this. Y, X. We are looking at sine 43 degrees. It can be here. So they told us that what we know, they said sine t equal, sine 43. Sine 43 degrees equals t. What we know about sine is that it is opposite over adjacent. This is similar to saying t over 1. Opposite over hypotenuse. This is similar to t over 1. So this is 1, and because it's opposite, it means we don't know what the x value is, but we know the y value is t. So we need to find the value of t. The value of x. So we will say r squared equals x squared plus y squared. Of course, this is Pythagoras theorem. Okay, this is Pythagoras theorem. What is r? R is the hypotenuse. It is 1. Alright, it is 1 squared. What is x? We do not know. What is y? It is t. So this is t squared. Therefore, 1 minus t squared equals x squared. Therefore, x is plus minus 1 minus square root of 1 minus t squared is equal to x. Now be careful. This was an acute angle. And since it's an acute angle, sine is positive in the first and second quadrant. So we took it to be the first quadrant because it's an acute angle. So we will say, what is this? Therefore, x is equal to positive 1 minus t squared. Remember, it can be both positive and negative, but because it is in the first quadrant, x value is positive. Okay, x value is positive. Now, let's now try to find number 1, sine 317 degrees. Where is it? 317 degrees is in the fourth quadrant, right? Because this is less than 90 but less than 180, greater than 180 but less than 270. Here, it's greater than 270 but less than 360. So it's here. So the reduction formula for this side here, 317, is 360 minus. Alright? It is 360 minus. A tip that I often give students is this. In the fourth quadrant, you say 360 minus. To get what your angle is, say this. Say 360 degrees minus the angle that is at the top there, which is 317. What is it? You will realize that it is 43 degrees. Right? It is 43 degrees. So in other words, we are saying 360 degrees minus 43 degrees is equal to 317 degrees. Can you see that? Okay. So this is minus 43 degrees. Now that you have written this as a reduction formula, you ask yourself, in the fourth quadrant, meaning in the 360 minus quadrant, which is the fourth quadrant, is sine positive or negative? Remember the cast diagram? Remember the cast diagram? What did we say? We said all students take coffee. So in this quadrant, only cosine is positive. So we will therefore say, because you are in the 360 minus sine, you are negative. And what are we left with? We are left with sine 43 degrees. So that 317 is similar to negative sine 43. If you want proof to this, I want you to try on your calculator, press sine 317, tell me what you get. Let me see. I think I have a calculator here. Tell me what you get. It's going to take forever. Does it have... Oh, no. It doesn't even have... Doesn't have cosines. Okay, cool. I'm going to let it go. All right. Sine 317, tell me what you got. Now, try negative sine 43. You will realize that the values are the same. Sine negative 43. You will realize that the values are the same. All right? Yes. So, what we are trying to say here, we are trying to say that sine 317 is equal to negative sine 43 degrees. Okay? We are trying to say this. Okay? All right. Moving on. We didn't answer the question. The question was saying we must express the following in terms of t. So we know that wherever we see sine 43, what do we see? We see t. So our answer is simply negative t. Okay, our answer is simply negative t. Moving on. Number 2. It says we have cos square 403 degrees. What I had said to you, I said to you, when a number is greater than 360, minus multiples of 360 from it. So in other words, it's similar to saying this is 403. 403, it's on the second revolution, so it'll be minus 360. Okay, what I mean is one revolution will be completed. To get 403, you must be gunning for a second revolution, but you haven't completed it. Okay, so 403 minus 360. What do you get? You get cos square, I believe 43. Cos square 43 degrees. All right. Now, what you know about cosine, is that cosine is adjacent over hypotenuse. Okay? And for this one, I need to make you aware this is similar to cos 43 degrees multiplied by cos 43 degrees. Okay. So we go into our diagram. Cosine is adjacent over hypotenuse. What is the adjacent side? It is square root of 1 minus t squared all over 1. Let's go. This is square root of 1 minus t squared all over 1. Okay? But squared. If maybe you get confused, I'm saying it'll be 1 minus t squared multiplied by square root of 1 minus t squared. Happy? So this will then become 1 minus t squared. Remember, you are in grade 11, so you know how to factorize or how to multiply or to work with sets. When bases are the same, you add exponents. For those that get confused, this is similar to saying 1 minus t squared to the power half multiplied by 1 minus t squared to the power half. The bases are the same. What are the bases? The bases are 1 minus t squared. You add exponents. What are your exponents? Half plus half. So what is this? 1 minus t squared to the power 1. Obviously, it is 1 minus t squared. Okay. All right. So this is number 2. Okay. This is number 2. All right. Let's then head to number 3. Number 3 said we are looking at tan negative 43 degrees. Negative 43 degrees. I said when you see negative angle of tangent and sine, you will say it's negative tan 43. Now, what you know, SOHCAHTOA, tangent is opposite over adjacent. Our opposite side, I think it was T. Yes, here is it. It was T. It was T. Our adjacent, we just said it was 1 minus T squared. So this is how you represent these, okay? This is how you represent these in terms of, or you express these questions in terms of T. Okay? All right. Now we're going to try another example. Now example 2 will say to you, simplify without using a calculator. Simplify without using a calculator. All right. Now we have number 1. We have cos 90 degrees minus theta over cos 360 degrees minus theta divided by tan theta minus 180 degrees. Number 2, we have cos negative 225 degrees multiplied by sine 135 degrees plus sine 330 degrees all over tan 225 degrees. Number 3, cos 360 degrees minus theta cos negative theta minus 1 all over sine 360 degrees plus theta tan 360 degrees minus theta. Let's try number 4. It is cos 315 degrees cos 405 degrees plus sine 45 degrees sine 135 degrees all over sine 750 degrees. Okay, all right. Let's try number 1. I want to change the color. Number 1, we have cos 90 degrees minus theta all over cos 360 degrees minus theta divided by tan theta minus 90 or 180 degrees minus 180 degrees. You have never seen something that looks like this. Okay, so we're going to simplify it. And this, because it's 90, cosine will change to sine. So this will become sine, but because it's also in the first quadrant, remember 90 minus is in the first quadrant. So it will be positive sine theta. Denominator, cosine 360 minus, let's go back, 360 minus is in the fourth quadrant. So cosine is positive, so you will leave it as cos theta. Right? It will be cos theta. Now, this one here, you need to simplify it. It has to be tan. I want you to take negative as a common factor. Okay? I want you to take negative as a common factor. What are you left with? 180 degrees minus theta. Now this is interesting. Sin theta over cos theta. There's something that you know about it. What is it? It is sin theta over tan theta. Sin theta over cos theta. It is equal to tan theta. Now, this, it's a negative angle. Let me put double bracket. It's a negative angle of tangent. What is it supposed to be? It's supposed to be negative. Then what are you left with? Negative tan, and then 180 degrees minus theta. Close and then close again. Hold on. You are not done. Remember we said angles given in when trigonometric ratios are given in angles that are greater than 90 degrees, you can write those angles as acute angles. We are going to prove that. Now, in the 180 degrees minus, let's remind ourselves of the cast diagram. This is our cast diagram. 180 minus is this quadrant here, right? Tangent will be negative. So this means you will have negative times negative tan. What are you left with? Theta. Okay? So as you can see, negative divided by negative is positive. I don't want to write this step, but because it's introduction, I will be writing it so you don't get confused. Okay? So you don't get confused. So this will then become tan theta divided by negative times negative is positive. Tan theta divided by tan theta. Anything divided by itself is 1. Okay? Anything divided by itself is 1. All right? Perfect. Let's try number 2. Number 2, we have cos negative 225 degrees sine 135 degrees plus sine 330 degrees all over sine 225. I often want to write this when I'm working with you guys from the lower grades. 90 degrees minus theta. By lower grades, I mean grade 11 until you get used to it. 90 plus theta, 180 degrees minus theta, and this is 180 degrees plus theta. Well, this is 360 degrees minus theta. Now, another reminder is that all students take coffee. I'm going to be copying this throughout. Okay. Now, cos, it's a negative angle. So remember cosine, negative angle of cosine is positive. So you will say it's cos 225. Hold on. And then what is sine? I can just simplify it and say 135 must be in this quadrant. In this quadrant, we work with 180 degrees. So to get this acute angle, just say 180 degrees minus 135. It must be 45 degrees plus sine 330 must be somewhere here. Alright? So here we work with 360 minus. So now hear me out. To get 330, you must subtract 30 degrees. All over 225 must be in this quadrant, the fourth quadrant. Okay, it must be in the third quadrant, sorry. So here we work with 180. So we work with 180. So do this. 225 minus 180, it must be 45 degrees, isn't it? Perfect. Now, cos 225, again, it's the same. It's in the third quadrant. So it will be cos 180 plus 45. My mistake here, it's supposed to be plus because it's 225. All right. Now, these we can simplify now. Cos in the 180 minus, where is it? It's here. Cos in the 180 minus is positive. So this will become sine 45 degrees plus cosine in the 360 minus. Why is 360 minus? It's this one here. In this quadrant, sine is negative. So it will be negative sine 30 degrees. Close. Now, sine in the 180 plus, where is it? It's the third quadrant. Is sine positive or negative? You said it's negative, so it will be negative sine 45 degrees. Moving on, we have cos in the 180 plus. Where is it? It's this quadrant here. Only tangent is positive here. So we will have negative cos 45 degrees. Now, for those who did not watch the video or the grade 10 video of special angles, when we want to find special angles without a calculator, you can still use your calculator. Nothing wrong with it. You can still use your calculator. However, some of us, we are lazy to go fetch our calculator. You will write this 2 lines and then in between, draw these 2 lines. In between, draw 3 more lines. And then you start numbering 0, 1, 2, 3, 4. All right, 4. Sorry. Then put colon in between them, semicolon rather. Then you started from the top to the bottom. Now start from the bottom to the top. Start with 0, then go with 1, 2, 3, 4. I want you to put square roots on all of them, but I don't have to put square root on 1. I really don't have to. Right? And 0. And as you can see, I also want you to add 2 here. This will be the hypotenuse. Okay? So, if you recall, this is adjacent, this is opposite, and this is hypotenuse. Remember, adjacent, opposite, hypotenuse. In other words, xy. So, what is sine 45? Here is it, root 2 over 2. You can press your calculator to confirm. Now, this is plus and minus, so it will be minus. What is sine 30? Oh, so this is 30 degrees. This is 45, and then this is 60. Now, sine 30, here is 30 degrees line. Sine is y over r, or opposite over hypotenuse. This is half. So it is half. Now, what is sine 45 again? We said it is root 2 over 2. We are not done. We are now going to simplify this cos 45. Let's proceed. Cos 45, what is it? It is adjacent over hypotenuse. Then 45 line is this one here. Root 2 over 2. Negative root 2 over 2 multiplied by root 2 over 2 minus half all over negative root 2 over 2. Alright? So we are sorted now. So you can, the question said you should not use a calculator. It said you should not use a calculator. So it's okay. I will act like I don't have a calculator. Negative root 2 times root 2 is basically root 2 times root 2. So it's basically 2. 2 times 2 is 4. So this is half. So what do you have? You have negative half minus half all over negative root 2 over 2. Okay? What is this? This is now negative 1. As you can see, it's negative 1 because you have negative half minus half. It's negative 1 over negative root 2 over 2. This simplifies to 2 over root 2. Because they said you shouldn't use a calculator, you can leave it here, guys. But if you like, you can then say this is 2 over root 2, rationalizing the denominator, times root 2 over 2, root 2 over root 2. Then what do you get? You get 2 root 2 over 2. Our answer is simply root 2. Okay? Our answer is simply root 2, square root of 2. Okay? So, take out your calculator and plug in this value as it is on your calculator. 1,41, but let's confirm. When you plug this value, we get, let me use my calculator, cos negative 225 close, sine 135 close, plus sine 330 close, all over sine 225 close. We get 2. What? We get root 2. So can you see? You were able to get root 2 without using a calculator. As you can see, this was very long because I want to make sure that you do not confuse anything. There are steps that we can skip. There are steps that we can skip, but I want to make sure that you guys are on the right track. Okay? All right. Moving on, we then go to number 3. Number 3 says cos squared 140 degrees plus sine squared 220 degrees. I'm going to copy this diagram. I need to use it all the times when I am working with you. Okay, I'm going to copy it. And now let me paste it. Okay, it's perfect. Now let me move it slightly. Okay, perfect. All right. Now we have equal to cos squared in the 140 minus quadrant. 140 degrees is in which quadrant? Is in the 40, isn't it? Is in the 180 minus. 140 is in the 180 minus, meaning it is in the second quadrant. So what do we say? We will say it is 180 minus 140. What is it? It is 40. So it's 180 degrees minus 40 plus sine square 220. In which quadrant is 220? It's here in the 180 plus. So 280 degrees minus 180, what is it? It's 40. So this will be 180 plus 40. Please pay attention. What you're doing in the brackets, you're doing something that when you add it, it must give you what is at the top. Can you see that? When you add 180 minus 40, it will give you 140. When you add 180 plus 40, it will give you 220. Okay? Perfect. Now pay attention. I already mentioned that when you have a square, it means something multiplied by something. So obviously cosine in the, let me perhaps write it here. Cos, let me do it like this, 180 degrees minus 40 degrees. And cos 180 degrees minus 40 degrees. We know this one here, cos in the 180 minus, which is this quadrant, is negative. It will be negative cos 40 degrees. It's the same thing. Negative cos 40 degrees. Negative times negative is positive. So you have cos square 40 degrees. Okay? So when you have a square, don't worry about the signs, as it will always be returning positive. So that means cos square 180 degrees minus 40 is cos squared 40 degrees. Plus, what is this one here? This is 180 degrees plus 40. Again, we know that 180 plus, sign in the 180 plus is negative, but because it's a square, it'll be sine square 40 degrees. Now, what do you have here? You have cos square 40 degrees plus sine square 40 degrees. These are equal to 1. Okay? Remember that square identity. These are equal to 1. Okay? These are equal to 1. All right. Moving on. We go into number 4. We have 2 more. This video is very long. Number 4. Let me copy it again. I'm going to copy that guy there. Let me copy him. So let me move him this time. I want to move him so you can see him. So number 4. Okay, I'm not going to use him, but it's okay. Number 4, we have cos theta over, oh boy, what am I saying? Number 4, we have cos 360 degrees minus theta and cos negative angle minus 1 all over sine 360 degrees plus theta and then tan 360 degrees minus theta. Okay, so what do we have? Cosine in the 360 minus, it's this quadrant here, is positive, so it'll be cos theta. Negative angle of cosine becomes positive cos minus 1. Sine in the 360 plus, be careful, this was 360 minus, this can be 360 plus. Remember, the theta is acute, so it's an angle that is less than 90 degrees. So 360 plus theta is the first quadrant. Now remember, in the first quadrant, all ratios are positive. So this will become sine theta. Now tangent in the 360 minus this quadrant here, what is it? It's negative. So it'll be negative tan theta. Okay? Perfect. What do we have? We have cos. So this is cos square theta minus 1. And then we have negative sine theta multiplied by sine theta over cos theta. Okay? Sine theta over cos theta. Oh boy. Okay. Now this is very interesting. Okay? Now this is very interesting. But it's okay. Do not worry. What we know cos square theta minus 1 is basically sine square theta. Okay? Again, what you are seeing here, you're seeing negative sine times sine is sine square theta over cos theta. Okay? Or let me just add this in the next page. Or, no, not in the next page. I can squeeze it here. Let me squeeze it here. Cos square theta minus 1 is sine square theta. If someone is confused, we said sine square theta plus cos square theta plus cos square theta is equal to 1. In the same vein, we can say sine square theta equals 1 minus cos square theta. Is this what we said? Yes. But now, pay attention. This cos square theta. It's not 1 minus cos square theta. So I will try to simplify it. Let me try to simplify it. When I try to simplify it, I will take negative as a common factor. So when I take negative as a common factor, what do I have? I have 1 minus cos square theta. Can you now see? Negative multiplied by positive 1 is negative 1. Negative multiplied by positive, negative multiplied by negative, it's positive. Hence, it's positive cos square theta. So we are okay. In the denominator, what do we have? We have sine square theta. I'm going to put it in a bracket. We have negative sine square theta over cos theta. Okay? Perfect. Now, this part here is sine square. Can you see that? The 1 minus whatever is sine square. But as you can see, these negatives will cancel. So we are left with sine square over sine square theta over cos theta. With this one, I like telling students that it's similar to saying, check this out, sine theta divided by sine square theta divided by sine square theta over cos theta is the same as sine square theta multiplied by cos theta over sine square theta. Hence, your answer will simply be cos theta. Okay, hence your answer will simply be cos theta. Can you guys see that? So this is how you attempt this question. Now, the last one. Let's try to push, guys. A fifth question says cos 315 degrees multiplied by cos 405 degrees plus sine 45 degrees and sine 135 degrees all over sine 750 degrees. So, something that I want you guys to see is this. You know that one revolution is 360. That's one revolution. Now, 2 revolutions will be 720. All right? Will be 720. That's 2 revolutions. So, 750 to me looks like it is more than it looks like it is more than 2 revolutions. So it'll be, you must minus, so for this, you must minus 720 from 750, okay? Which will be 30. So it's okay. What I'm going to write is this now. It's okay, you can write it like this, repeating everything because, and oh, there's another 405. 405 is greater than 1 revolution. So let me also note it here. 405 minus 360, it looks like it is 45. Okay, it looks like it is 45. Right? It looks like it is 45. So you can say this is cos 45 degrees plus sine 45 degrees sine 135 all over sine, what did we say 750 was? Sine 30. Do you guys see that? It's okay. Now, let's proceed. We have, what is 315? 315 is in the 4th quadrant, so we will say 360 minus 315 must be 45 degrees. But because this one is 45, for now, I'm going to leave it as it is. I know it's a special angle. I'm going to leave it as it is. Or let me just simplify it. It will be root 2 over 2 plus sine 45 again it's also root 2 over 2. If you don't know, let me show you. 45 cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. Okay. Now, sine 135 will be, it's in the second quadrant. I can say 180 degrees minus 45, I believe. And it's okay. Sine 30 is half. Let's go back to confirm. 30 is opposite over hypotenuse. Yes, it's half. Okay. Cos in the 360 minus is positive. So this is cos 45 degrees multiplied by root 2 over 2 plus root 2 over 2. Sine in the 180 minus, it's positive. So this is multiplied by sine 45 degrees all over half. Okay. All right. So cos 45, we said it was root 2 over 2. No worries. So this is root 2 over 2 multiplied by root 2 over 2. Right? It's okay. Now what is this? This is root 2 over 2 multiplied by sine 45 is still root 2 over 2 plus root 2 over 2 multiplied by root 2 over 2 all over half. Now this, what is this now? This is root 2 over 2 times root 2 over 2. It's 2 over 4. So this is half plus half all over half. Remember, they said we're not using a calculator. So we will act as if we don't know that we can use a calculator. Our answer is simply 2. If you're asking yourself why, half plus half is equal to 1 plus 1 all over 2, which is 2 over 2. It is equal to half. Now, 1 divided by half is basically 1 multiplied by 2 over 1, which is 2. Hence, your answer is 2. Now, let's go confirm this on our calculator quickly. Our beautiful calculators, let's use them. Cos 315 close, sine 405 close, plus sine 45 close, sine 135 close, all over sine 750. What is our answer? My calculator gave me 2. What is our answer? Our answer is simply 2. So with that being said, we have completed everything that you need to know for reduction formula. So now you can go to your exam and ace your reduction formula. With that being said, it's a wrap. See you next time and bye-bye.